Grade 12s, welcome back to another video. So today I am starting, this is the first video for the examination summary videos that I will be dropping. So I am dropping a whole playlist on acids and bases. It's a revision. So I'll only be having short videos for about 5 minutes max, or 8 minutes, let's say, if it's long, in this topic. So make sure you watch the video after this one. You probably have about 6 or 8 videos on acids and bases. So guys, make sure that you watch it and you are up to speed. So I'll just be dropping playlists every day. Instead of making it a long 40 minutes video, I'll just be making short videos that you can just watch, tackling specific problems you have with regards to acids and bases. So let's get right into it. So the most important thing with acids and bases, number one, that you have to know, guys, is you have to know how to define acids and bases. You have to know how to define acids and bases according to Arrhenius and Lowry-Bronsted theories. So it's actually very important. So Arrhenius says acids produce hydrogen ions in aqueous solutions. So that is what he believes. So the H becomes positive and it has H3Os. You will see when we are doing reactions that whenever you have acid, you are going to have an H3O in that equation as an outcome. And then it says bases produce hydroxide ions in aqueous solutions. So you will have an OH and a negative here on top with regard to bases. So keep that in mind. Go to your examination guideline and check which definition, word to word, because keywords are very important. So this was written according to the examination guideline anyway. So this is the definition of Arrhenius according to the examination guideline for grade 12s. So the Lowry-Bronsted theory says an acid is a proton donor. So know that Lowry-Bronsted says an acid is a proton donor and a base is a proton acceptor. That is the easier explanation. That's all that you have to know, okay? With Lowry-Bronsted theory, that an acid is a proton donor and a base is a proton acceptor. So keep that in mind. And then another thing we have is a strong and a weak acid, okay? Strong acids ionize completely in water to form a high concentration of H3O ions, and weak acids ionize incompletely in water to form low concentrations of H3O. So you have to know that strong acids completely ionize in water, means they completely mix with water, okay? So strong completely mix with water, weak acids incompletely mix in water. So they form, because they incompletely mix with water, they form low concentrations, right? So weak acids form low concentration, while strong acids cause high concentration in water because they mix completely with water. Know the difference? It's very important. And then we have strong bases. Strong bases dissociates completely in water to form high concentration of OH ions. So dissociate means they don't mix with water. Bases and water do not mix. Just know that. So they do not dissolve in water, bases, while acids can. Bases don't, okay? So they dissociate completely in water, and weak bases dissociate incompletely in water to form low concentrations, okay? They all, the other one, the strong one, dissociates incompletely in water to form high concentrations of OH ions. So there is more OH in it not mixing with water makes it form high OH ions, right? So, and the weak base, this dissociates incompletely in water. So because it dissociates incompletely in water, it forms a low concentration. So meaning a tiny bit part of it is able to completely dissolve in water, a little bit of it. So that is decreasing the potency of the base, of a weak base. So I hope you found this information very, very helpful. And taking it again, just on a slow pace, is that strong acids ionize completely, right? When you see a strong acid, it ionizes completely in water and forms a high concentrate. And then when you see weak acids, they ionize incompletely in water to form low concentrate, right? So whenever you see H3O, we are now dealing with acids. And when you see OH and a negative on top, we're dealing with bases. So a base dissociates completely or dissociates incompletely. So the one that dissociates completely have a high concentration of OH, and the one that dissociates incompletely has a low concentration of OH. Thank you very much for watching this video. On the next video, I will be showing you the difference between acids and bases and their reactions.